Living green or sustainably is about more than saving on your electric bill and doing your part to protect natural resources. It is about a safer and healthier life for you and your family without sacrificing style, quality, or budget. This is a movement to provide all of us with clean air to breathe and water to drink, safe, healthy food to eat and places to live, and energy to run the places where we live, learn, play, and work. The Everyday Green Home Podcast helps you get the value of green for you, your family, and your community. Whether it's green homes, green living, or the people who make it happen, join me, Marla Esser Close, to learn how green and sustainability practices and products work for you and our world. I am really excited about today's episode. I get to do something I've never done before. I get a chance to work with my son. It's pretty cool. So I'd like to introduce you all to my son, Trent Esser. How are you today, Trent?
Good. Glad to be here.
So you are starting up a company right now.
Yes, I'm starting up a company in St. Louis. We're currently in the beta testing phase. It's called Printerior.
Printerior. I love that name. I'm always making up words, so that sounds like one I would make up. Maybe that's why you made it up.
Yeah, you just shoved the word print and interior together, and it came up with the original concept for our business. So it wasn't too big of a stretch there.
You are your mother's son.
I told him we'd pick on him today. So, hey, y'all, I'm Marla, the Green Home Coach, and Tony, dedicated co-host here today.
Very dedicated.
You are dedicated today.
Fourth episode in a day.
I know. We are cranking them out today. We're having a bulk recording day today. And we are enjoying very much being back in studio in the beautiful Shock City Studios in not quite downtown St. Louis.
It's St. Louis City.
There you go, St. Louis City. And the timing was perfect because, Trent, y'all are getting ready to launch.
Yeah, we are. Hopefully about here in a month. We're planning on 2 to 4 weeks. We're going to have our first product launch.
Which will be in July.
Yep, we're early July is the goal right now. Just trying to get the last finishing touches done on everything.
So I'm going to get an opportunity tomorrow to go out and see their production facility.
Oh, that'll be fun.
Yeah.
Have you ever been there yet?
No. You guys just moved in a few weeks ago, right?
Yep. We just moved in about a month ago and finally kind of getting everything set up. It was a construction site for a little bit, so not the most pleasing place to the eyes.
Oh, that's okay. It's better for now, right?
Oh, yeah. Yeah, much better.
It's all part of the process.
Of course. The process always takes longer than you think it will.
It does.
Especially right now.
Yeah.
We talked about that 2 podcasts ago.
Good luck, y'all, keeping track of all this.
Yeah.
Just listen a lot and you'll be good. So tell us what Printerior is all about. What's the basic mission and goal of Printerior?
So we're a sustainable additive manufacturing company.
In English?
So our goal is to help solve the world's plastic waste problem by using 3D printers and waste plastic to create sustainable products.
Wow, that's a mouthful.
Yeah, working on getting it down.
So let me make sure I got this straight. By the way, I kind of have a heads up because you've been talking to me about this for a while now.
Oh, yeah.
That this whole idea of 3D printing is exploding.
Yeah, in almost every sector.
This whole idea of manufacturing things by adding product rather than removing is huge.
It's a completely new way of manufacturing almost anything and everything, and it's really taken a while to get a start here in the U.S., but we're working on accelerating that start.
And lastly, you use already existing plastic for feedstock, so I've got to pretty much guess there's an unending supply.
Oh, yeah. It goes on for quite a while. I don't think we could get through it in this lifetime.
So right now, y'all are producing what we can see on the table here, so I'm going to try to describe it. It almost looks like wire, this filament.
Yeah, so right now what we're doing is we're creating 100% recycled filament for 3D printers. So it's basically, think of like the ink in an inkjet printer.
Okay.
It's what allows the printer to build up layers and actually build its shape. And so it's the actual plastic that makes every print.
So is plastic the only thing you use for 3D printing?
Different variations of plastic, yeah. So you have your bioplastics, which are traditional. It's called a PLA. And then you have all your other kinds, which can range from, ABS to PTG to a wide book of variety, all depending on what your application is.
I thought I had a lot of acronyms.
Oh, the acronyms in the plastic industry could go on forever.
So you say bioplastic, that's the ones that are made from plant as opposed to petroleum.
Correct.
So if you don't know, folks, most plastics traditionally have been made from petroleum products.
Almost all of them still are.
And we are starting to see more frequently plastics made from, cornstarch, potato starch?
Yeah. The most common here in the U.S. is corn.
Okay. So if you pick up like a plastic fork and it says compostable on it, that's usually what it's made from, right?
Yeah, usually it's made from a material called PLA, which is a bioplastic made from corn here in the U.S.
And when they say compostable, what do they really mean?
So that's something that we're trying to educate on right now, actually. It's really been branded as an eco-friendly plastic, but in reality, it's kind of not. The problem with it is that even though it says it's compostable, it's only compostable in a commercial composting center, which very rarely exists, and very few of them will actually take plastic, and of any kind.
So I can't put it in my backyard compost pile?
It would take you quite a while. I'd say 5-6 years, maybe.
Oh.
That's a long time.
So it's wish composting.
Yeah. You need a lot of heat and a lot of pressure to actually compost it.
They're saying it's compostable. They're not telling you by what.
Well, that's
Exactly.
true. I know if you read the small print on the box, they'll say like industrial compostable facilities only, blah, blah, blah. However, it's got a better shot of biodegrading eventually than a traditional piece of plastic, right?
Yeah, a little bit. They show some degradation higher than traditional oil-based plastics, but it's not as significant as they would like it to seem. Yeah, the advertising isn't what it actually is.
Okay, so when you make a product from recycled plastic, it's not compostable unless it's plant-based plastic.
Yes.
But we are using a waste material. Is that correct?
Yeah, so we really came at this with a circular mentality to the market. 3D printing really took off in the last couple of years, and then once COVID hit, it's skyrocketed. And that means the amount of waste that's been generated has also skyrocketed. And so what we did is we basically came in and said, we're going to make our material from 100% recycled sources, and then we'll collect the material once you're done with it. So we provide a full recycling service as well for collection of all 3D prints.
So like what kind of places would that be where you would pick up recycling from 3D printers?
Yeah, so we work with universities, school districts, maker spaces, and small-scale businesses that use 3D printing as their way of manufacturing their products.
Okay.
And prints fail. That happens all the time, that a product won't come out the way that you want it to, and so that scrap usually just gets thrown away. We turned to them and said, hey, we can incentivize this too. So not only can you recycle it with us and we'll turn it into a new material, but we'll give you a discount off of that feedstock that you need for next time, which is our filament.
Kind of like incentives that you get for buying an energy efficient heater or cooling. Absolutely. Yeah, I like that idea.
Absolutely. That's actually a good way to look at it.
Yeah.
Kind of like the old-fashioned deposits on bottles.
Yeah, same thing.
So tell us how this all, before I go there, this sounds like making plastic from recycled plastic should be easy. So why isn't everybody doing it?
It sounds easy in the grand scheme of things. Once you get down into the fine details, there's a lot trickier of methodology in it, and making sure that you're getting the right feedstock, that it's clean, that it's being formed the right way, and that it's coming out the correct consistency and correct material qualities and all that kind of stuff. But a lot of people aren't doing it just because to do all of that effort isn't cheap. And it's a lot more effort than it takes to just call up a company and buy new plastic. So they just don't.
So you have to be as easy to buy as new plastic to be competitive?
Correct. Yeah.
I don't know.
So basically, for the same benefit, you have to put forth twice the effort.
A lot of the starting effort, yeah. So once we kind of got everything established, it's, pretty smooth sailing from there. But yeah, the R&D work, trying to get it all figured out, definitely is a lot more time consuming than most companies are willing to spend when the market is already buying the stuff that's brand new. And nobody has made too much of a stink about it.
Okay. So what will you be making?
So right now we make filament for 3D printers. We also run a print farm so we can make products. We have about 20 printers in there that can make pretty much any product that you could think of within about a cubic foot size.
I can't wait to see this.
That's just the great thing with 3D printing, is that it's not most manufacturing methods currently allow you to make one thing, and that one thing is all it can make. And it's really expensive to make that, to start up and make one single thing.
So like injection molding kind of stuff. Like the cover to this mouse is probably injection molded.
Yeah, and the mold to make something like that would probably cost you close to $10,000, if not more.
Ouch.
Yeah, and so for a small business to make something out of plastic, it's just not affordable to go that method. So we see 3D printing as a way to help spark entrepreneurship and startup mentality to bring new products to market quicker without the large cash requirements that it requires to make plastic products because of molding costs.
So does it cost you basically the same amount to make one product or to make 100? I mean, times 100, obviously.
Yeah, so our 3D printing has so far been cost competitive up to about 50 to 100,000 parts. After that, injection molding is more cost effective because they can just do it quicker. But 3D printing allows you to, prove that your idea works, sell, 1,000, 5,000, even 50 of the product that you want to make. And then if you can work up the cost to get to injection molding, then great, you have a pretty good company going.
Yeah.
I was going to say 50 to 100,000, parts. That's a whole lot.
That's a lot. Yeah, it's a lot of units. Yeah.
Yeah, I can see all kinds of opportunity.
Yeah. Well, one of the things that's sitting in front of us right now is actually a COVID face shield. These are the visors that they use in hospitals. And that was a huge thing that people took off during 3D printing or during the pandemic, was that hospitals were short on supply and manufacturers couldn't tool quick enough to create the supply. And so 3D printer communities from around the country banded together to basically start making these and made millions that went out to hospitals in days, not months.
Because they were flexible. They could do it really quickly, yeah.
Because all you had to do was download a design and click print.
Wow. So it's kind of the opposite of the numerical control programs that I remember back from CAD CAM days.
I'm going to, not even comment to that.
Well, you would take a 3D model that you made in a 3D system, and you would have a tool that would cut away the material, the numerically controlled machine. And that's the way we've traditionally manufactured, either that or molded, right?
Correct. Yeah, I think what you mean is subtractive.
Correct. There you go. Thank you.
Yeah.
We didn't use that word then.
Yeah. So we work in 3D printing is technically called additive manufacturing because you're building up the layers. Subtractive is when you're taking away, you basically start with a cube or a cylinder and then you carve that shape out of it. And so we're actually working our way up into getting to large format printing so that we can print large things, even a boat,
Whoa.
Very, very large is what we're shooting for. And so that uses a method that's additive and subtractive. So you go in and you print all of the layers of the rough shape, and then you can take what is a CNC mill and you basically finish off the surface so that it's nice and shiny.
Huh.
I do know 3D printers are starting to find their way on construction sites. There are developments being made with 3D printers in concrete.
Oh, yeah. That's a huge market right now. It's trying to figure out some stuff in the autonomous building industry.
Yeah.
And it's been crazy interesting to watch because the pace of acceleration is so quick.
Well, it's nimble. You can see how that could move quickly.
Yeah, plus, they're looking to, help mitigate the labor issues.
Well, maybe even materials.
Yeah, that too.
Yeah. There's a couple companies right now that are looking to integrate 3D printing homes with their autonomous building platforms to try and do a full no human build site. And I think that would be a couple of years down the road, but an insane
Exciting
venture.
And scary all at once.
Yeah.
Yeah.
Now you just have to figure out how to program the 3D printer, right?
That won't fly in St. Louis because of the union issue.
Yeah, I don't know. I don't think the unions would like that, and not as much. But who knows? Maybe there will be a programmers union.
Yeah.
So before you launch into telling us more what all these items are here on our desk, tell us a little bit about how you guys got the idea for Printerior, and you and your partner Hayden known each other a long time.
Yeah. We've known each other since high school. We actually became friends on the swim team freshman year. So we were both in college together because we ended up going to the same school. And he had gotten really into 3D printing. And obviously I knew a lot about the sustainability industry from the other person sitting here. And so we were talking about it one night, and I asked him if he'd ever heard of somebody using recycled materials in 3D printing. And he'd said, no, not really. And so we started kind of doing some Googling and searching everything that we could. And kind of came across that there was a real lack in the market for it, but there was a huge demand that nobody had really filled. And us being sculptors and designers, we wanted to make big things. We thought, desktop printers are really cool, but what if we could make a chair? What if we could make a table? What if we could make a, 6-foot tall sculpture? So we got really into what is called large format printing, which is where our company will be going eventually. And, we participated in the University of Missouri EQ Accelerator, which is also called Entrepreneurship Alliance. And we ended up receiving some seed funding from them, which was really great. I love the program and I can't say enough good things about them. And basically after that, I went to Europe to go study with some large format 3D printers and kind of learn what the deal was and how everything worked. And I got there and I saw everything and I was so psyched, and we were ready to bring all this technology back here. And I came back here on
March 7th.
Yeah, March 7th, 2020. I got back to the university.
I remember because I picked you up.
One week before.
Yep. I got back here and I got to the university and I was sitting there and we were discussing everything, trying to get all the plans going. And I left for the weekend and all of a sudden everything shut down.
Yeah, because St. Louis shut down that next weekend.
Yep. It was immediate. And I called our friend, I called our guys that we just made deals with over the Netherlands to partner. And they were like, our factories are closed. We got nothing for you. And so I was like, okay, what are we going to do? So we kind of just thought it was going to pass, waited it out, stuck to our guns. And, once things started settling, we reached back out to them and they said the timeline was going to be, over a year for us to get stuff going. And so we decided, we're like, okay, we have to pivot. We have to decide something new. So we took our idea wanting to use recyclables and 3D printing, and we pivoted into making filament for the consumer market. And so that's kind of where we're at now. We, built our own extruder to really learn everything that we could about the market. And then we went in and we bought a really big production line, and we just sat there and tested it until we decided that we had a product that we liked. We had a material that we liked. And that's kind of where we're at now. And so now basically what we're doing is we're trying to wrap the whole product itself, everything from the postcard that's inside to the plastic that's wrapped around it to the spools themselves, which that spool is plastic right now, but it's going to be cardboard. We're waiting for the next batch of those to come in. And so we want everything to be either easily recyclable, not just recyclable, easily recyclable, and coming from a sustainable source. And it either needs to come back to us or it needs to go to a municipal facility that it will be dealt with, not something that might be dealt with. And so we're trying to really wrap our whole brand around that side. And so all of our filament goes out to consumers, and they're, extremely encouraged to, if they have failed prints or they have things that go wrong, to send it back to us. And so obviously we have a bunch of materials that are here, and not going to go too technical into them.
So back up a second. So tell us a little bit more about your recycling program, because this is kind of novel from what you've been telling me.
Yeah, again, we work with universities, makerspaces, colleges, and individuals, especially large. There's plenty of people that have, 5, 10, 20 printers in their garage.
That's crazy when you think about it.
I know. I was doing some research for some stuff, to help him with some things a few weeks ago, and I about fell out of my chair when I saw the numbers of how fast 3D printing has grown and how widespread it's become, because everybody can own a 3D printer now.
The cost of a 3D printer for the home is pretty cheap.
Yeah.
Oh, they got so cheap.
Yeah.
When I was in high school, they used to be the size of refrigerators and cost you $20,000 or $30,000. Now you can go out to Best Buy and buy one for $300 to $600,
yeah.
And that's a good printer. It's the ones that we use are the same desktop printers that an average consumer uses. Sure, you can go up and buy the industrial stuff that's still going to cost you $20,000, but it's not always needed in most circumstances.
Right. I know the engineer, our lead engineer at work, he's got his own 3D printer, and every once in a while he wanders in and puts some new knickknack on his desk. He's like, I was bored last night.
Yeah.
And plop.
Mm-hmm.
But I think a few years ago, we all thought 3D printing would be great for prototyping and small runs, but this has taken off way beyond that.
Yeah. Price became competitive, and that's, the leader in any market. Once the price became competitive for buying a machine, running a machine, and the material became, cost effective, it's taken over a lot of small to medium sized production runs for people. And it's really allowed, especially with the growth of STEM in schools, I have school districts that I talk to that they have whole curriculums based around 3D printing and additive manufacturing.
That's cool.
Well, and they should. I mean, that is the future of manufacturing.
It is. And I just talked to a teacher the other day that's working on an industrial arts additive manufacturing program. So he's working with the arts department and the STEM department to try and merge the two. And I love that because that's right up my alley as a designer and a 3D printer.
Well, that makes sense because it's the science of how it's made, but it's the designer of what is made.
Exactly. It's the way to merge the two.
Which makes perfect sense for you and Hayden.
Yes.
So when these guys were seniors in high school, they're both amazing artists. I'm going to brag on my son here and Hayden.
You're biased.
Well, if you saw the pictures, you might think otherwise. So they each had, for their senior project, was it AP that you were in?
Yeah, AP.
So they had a booth that was what, 10 by 10?
Mine was pretty big. Yeah.
Filled with their work.
Cool.
Big pieces of work. I mean, your one piece was what, 8 feet, 10 feet tall?
Yeah, it was 8 or 9.
What was your main medium?
Sculpture. I worked in a weird kind of phase because I like to blend mediums and materials. And so a lot of my stuff was basically showing like how to transition materials. And I worked a lot with natural versus industrial, which kind of fits where I'm at now.
I was going to say, now that I'm looking back, I see the writing on the wall.
Yeah, it kind of all fits together.
You did a lot of setup then, but they're both artists. Trent's the business, the entrepreneurial, the go give it a shot guy. Hayden's the engineer and designer. So I think you guys are extremely well suited to work together.
Complementary skills. You got to like that.
Yeah. And then we brought on a third co-founder. His name's Jordan, and he holds about 6 or 7 degrees, all in computer science and electrical engineering and the gambit of anything in the engineering school. And so between the three of us together, we can pretty much solve most problems that are mechanical, electrical, or design oriented.
Crazy stuff.
Yeah, it is.
This is how we start making a dent in climate crisis, which plastic is part of.
Well, manufacturing is part of.
Manufacturing is part of it.
Manufacturing, you could say, has a huge footprint in all this.
Yeah.
So this is how we start making a dent, is one solution at a time. And who knows, maybe we're looking at the next big thing. I hope so. I'm ready. I'm ready. You're ready. I know you're ready.
Oh, yeah. Always chomping at the bit for something new.
So it's kind of crazy that I'm sitting here looking at this reel of filament.
It just looks like wire to me. And
it does. It looks like the old phone wire, if you remember the coated phone wire.
It actually looks like 22 gauge wire that we use for older style security systems.
Okay. Mm-hmm. So actually, this is a plastic filament, yet it has to go into the 3D printer where it's basically melted and redeposited. Mm-hmm. So it has to be reformed. So I'm sure you have to have some properties of it that are a little different than just other kinds of plastic.
Yeah, the plastic ranges of materials are pretty infinite at this point. So we work with about 4 kinds of plastic right now that are very specific, and they obviously have to have their properties of strength and or have the right amount of elastomer so they can stretch, but they need to be able to cool quick enough to hold their shape. There's a bunch of different requirements that go into it, but that was one of the things I did not expect when I got into this business was the amount of time I would have sourcing plastic and calling plastic providers and recyclers and all that gambit. It's the book. You could write a 10,000 page book on the amount of plastics there are in the variants. And it's its own language when you talk to a plastics broker.
Well, my understanding is that is one of the big reasons we're not recycling so much plastic is because it's too many variations, and that makes it too hard.
It is. Yeah, that's exactly the reason.
If it was 2 or 3 different types, It'd be easy. But when you get into 100, yeah. Okay, that makes sense.
And then you blend products, like you might have a freezer box that has plastic embedded into the cardboard.
Right.
Well, now you can't do anything with it.
Oh, yeah.
Because you can't separate the plastic from the cardboard.
Now, for example, we work with a material called PETG. It's the blue one that we have up here. I accidentally on an email missed the G, and I just put PET. And the guy emailed me back, and he goes, what are you looking for? There's so many different varieties. So I did a quick Google search. There are 160 different varieties of PET.
Oh my gosh.
Whether it's PETE, PETG, PET, it goes on. And there's every sub, and you're like, I don't know. Let me do some research and get back to you.
Okay, for starters, which kind of plastic is PET?
PET is actually an oil-based plastic. It's the same one that is used in water bottles, and then they add a glycol molecule to it.
And what happens when you do that?
It gives it a little bit of different properties. So like if you think water bottles are really thin-walled, PET doesn't like to be a thick wall, which is traditionally what you have in 3D printers. So if you give it that G, it allows it to build and stick to itself better, and it doesn't warp as much. So like it doesn't pull up on itself.
So you can have thicker walls on it.
Yep,
Gotcha.
exactly.
So you're able to find already out there used PETG, which you then in turn make into the recycled filament.
Correct. Yeah, we get this from an industrial source, and basically it's their scrap that they were just going to landfill because it's not worth their time to go and recycle it.
It'll be really interesting to see, down the road a bit, how much plastic you are able to avoid being landfilled.
It's crazy. So for every 100 spools that we sell, it's about 81 cubic feet of landfill space.
Wow.
Yeah. And there's arguably millions of spools that are sold every year in the U.S.
Y'all are my heroes. Okay, so real quick, because we only have a few minutes left. There's a bag of... I took some pictures that we'll post with the podcast. So there's the blue ones, which are the PETG. These are pellets, little pellets of plastic.
Yep, correct.
And then what's the white one?
So the white is what we were talking about earlier. It's that bioplastic that's called a PLA. So that's made out of corn.
Okay. And you can recycle that as well.
Yep. And so then if you go over to the next one, so this white, the one in the middle is a virgin plastic. And then if you go one over, that's PLA, but it's recycled.
Ah. Very cool. Very, very cool.
Almost looks like what you would put in a beanbag chair.
Yeah, same thing.
It does look like that.
I never knew those were actually plastic until I got into this industry.
Right.
Back in the 70s, they were styrofoam.
Yeah.
Well, that's plastic too, in a form of it.
That's true.
Everything's plastic when you're
Pretty much. There's plastic is so pervasive in our lives, we really have no clue where all it is.
Yeah. And it's incredibly energy intensive to produce.
Yeah, that's true. So very many different aspects that you are able to touch with this one set of solutions.
Yeah.
We're excited for you. So what happens next for y'all?
Thank you. Yeah, no, we're getting ready for this product launch here that's going to be in early July. And we're going to launch a couple different lines of our filament. We're really excited to get that out and going. And we're kicking off some print farm services. We're beta testing it with a couple small businesses here in St. Louis right now. And eventually we're going to open up an online platform that anybody can submit prints to, and we'll print them for you and ship them to you. Those will all be out of 100% recycled plastic, obviously. And then down the road here, hopefully in the next 6 months, we're going to get a large format printer in our space so we can work with some local designers and artists to make huge prints. And that's going to be really exciting. Get some chairs and tables, and we've already talked to a couple sculptors and all that jazz. So yeah, it's exciting. We're growing quickly, and the demand has been crazy even before launch. So
that's a good sign.
That's always good. Absolutely.
You know what all of our gifts are going to be in the future.
Yeah, no doubt.
Yeah, I'll print you something.
Just let me know when you can print the boat.
Oh, yeah, I will.
So where do people find you?
It's printeriordesigns.com, or you can go on our Instagram, Facebook, LinkedIn, Twitter. I think we got them all.
And it's Printerior or Printerior Designs on your socials?
That's Printerior Designs on our socials.
Okay. So we cannot wait to see where this goes. We hope to have you back sometime in the future and hear all about the success. So
yeah, thank you for having me. It's been a great time.
Well, everyone out there, check this out. I am incredibly proud as mom, as coworker, colleague, and fellow hero for the planet. Hero for people, really, right?
Yeah, we'll go with that. I just hit follow on Instagram, so I'll see when you have the boat ready.
Okay, I gotcha.
Okay, everyone. Have a great green day. That wraps this episode of the Everyday Green Home Podcast. Get the show notes with all the resources mentioned in this episode. And be sure to subscribe on your favorite podcast app so you never miss an episode. Ready to get started? Get more information, how-tos, and resources in my private Facebook group, Love Your Everyday Green Home. See you there. And remember that living a little better and a little greener is easier than you think.